Okay, this is 7.RP.2.b, 7th grade ratios and proportions, standard 2 subpart B. And what we're going to be doing today is we're going to be talking a lot about this constant of proportionality, also known as a unit rate, formerly known as the slope, which we've been talking about. And we're going to try to recognize what this unit rate is in graphs, in equations, and some proportional relationships today. Some terms to know, please get these down in your journal and define them. All right, first let's talk about a unit rate. Now we've discussed this a little bit in the past, recently, and we had some examples that we dealt with, and one of them was $20 for 10 apples. So if you go over to the grocery store and they say you can get 10 apples for $20, but you really don't want that many apples. So what you want to do is you want to find out the unit cost. So how much would it be per one apple? And we decided that we are going to be taking our numerator and dividing it by the denominator. So you're going to take 20 and you're going to divide it by the denominator of 10, and that you're going to get 2. Oops, sorry, 20. Let's do that the right way. So 2 times 10 is 20, and your remainder is nothing. So we know that if it's $20 for 10 apples, it's going to be $2 for 1 apple. All right, so we have the second example on the right. Let's say that grandma's house is 120 miles away and it usually takes us 2 hours. That's quite a long ride, so we're going to need a stopping point, maybe to use the restroom or to get a snack, maybe stop at a restaurant to get some food after an hour of the drive. So how many miles would we have gone at that point of 1 hour, so the unit rate? So we take our numerator again and divide it by the denominator. 2 goes into 12, 6, and 2 goes into 0, 0 times, and we have 60 miles in 1 hour. So we're about halfway there. All right, let's look at this table of values. It looks like we're comparing chores completed and money earned. So is there any relationship that you see between we'll call them our inputs and our outputs? Is there any numerical relationship that you see there? Okay, good. What you're seeing is you're going to be taking your x's and multiplying them all by 5 to get your y values. So if you take that, y is going to be equal to 5 times your x values, and that is always the case all the way down this chart. So 8 times 5 and 4 times 5. All right, so we can gather an equation from this table of values saying that for every y output, we're going to be taking our input x and multiplying it by 5. So our constant of proportionality, or in other words, our unit rate, or in words that we have used recently, our slope, our rise over run, is 5. All right. Using that same idea, we have a piece of graph paper here with some number values. I don't have anything compared right now. You can make up your own examples for your inputs of your x and your outputs of y. And if there is a relationship, we're going to have to go try to find it. So let's take out our pencil and make a bunch of dots where we see our line hitting the grid lines. Okay. And I can take any two random coordinates and check out the rise over the run and see if we have common relationships between them. So let me put my cursor on, let's just take this one right here. So if I were taking my y value, this is my y-axis right here. So if I'm taking my y value, that would be a 4, and then my x value, so if I have my y value being 4, that's my rise. And what would my run be? So if my rise was 4 and my run, I come over here, it is also 4. So I went to the right 4. And I simplified that. What would my rate of change be here? What would my constant of proportionality be? Well, 4 divided by 4 is 1. Well, let's see if that's the case for another point. How about, let's take that cursor and drag it maybe all the way up here at the top. Okay, so if I'm doing my rise over run, my fraction, and that point up here is at what? If this is 10, that means my higher value, we're going by 2's. What are we going by? 8, 9, 10. We're going by 1. So that would be a 11. So I rose 11. That means when I come over here on the bottom, I'm running 8, 9, 10, 11. Let's see if that matches up. Okay, so we do have a constant rate of change. When I rise 11, I run 11. And if I were to simplify that, that also reduces down to 1. Our constant of proportionality, or our rate of change, is 1. Okay, a little bit more difficult example. I've used some numbers that aren't common on my x and y axis. They're not the same on both of the axes, so I'm going to have to do a little bit more searching here. So let's take that cursor and take any point on the line. I'll just take, it looks like this one right here would work. Okay, so let's set up our fraction. Our rise, again, we start with our y-axis for our rate of change. So the rise would be 24 up, so up 24. And then our run, we ran over here, so that would be at 16. So we went to the right, 16. And let's reduce that. What is that? So what goes into 24 and 16 evenly? You're probably thinking right off the bat 4. So 4 goes into this 6 times, and 4 goes into that 4 times. Uh-oh. Is that simplified? No, hopefully you were thinking the 8 would have gone into them. Either one works. They both reduce down to 3 over 2. Now, if we have a constant of proportionality, or a constant rate of change, that means I can take another point on this line and it would also reduce down to 3 over 2. So how about we just take this first one right here. So what is that? As we rise 12, right, we went up 12, our run left us at 8. So if I were to simplify 12 and 8, well, 4 goes into 12 3 times, and 4 goes into 8 2 times. So we have our constant of proportionality of being 3 halves, 3 over 2. And then the last part of the standard, they would like us to recognize these constant of proportionalities, these common rates of change, and extracting them from equations. So simply in the first one, I see that we have y equals 10x. So my slope is 10 over 1. So my constant change would be just plain old 10. We have 8. And over here we have 1/2. Okay, in your journals, I'd like you to define the given terms on page 2 of the flip chart and write a few sentences on anything new that you learned from this video. and bring those questions to class as we always do. You know, I kind of went through that last screen there with the equations quickly, so we'll do many more of those in class, and have a good day.